Let's run our first MapReduce job with Python. Before we start, make sure you have a few files downloaded. You can visit my website, datapower.com. Go ahead and download the mapper, nysc_mapper.txt, nysc_reducer.txt. We also need the input data files, nysc_data.txt. Once you have these three files, we are ready to start. Go ahead and start the cluster, and we are ready to perform a MapReduce job with Python. The cluster is up and running, and let's copy the SSH string, open the terminal, paste. Now we need to make sure that the extension is the correct extension. I believe that when I saved this new key, I had the CER extension. Let's double check. Searching my demo in this Mac, and yes, the extension is CER, so I'm going to make that change. I also add the downloads folder because I know that's where my key is stored. Hit enter, and the connection to the cluster is established. One more quick point here. My demonstration is based on a Mac computer. The instructions for Windows users are slightly different, and they are provided in one of the previous video tutorials. This is a cluster that I have used earlier today. As you can see, there is a MapReduce directory already there. That is an empty directory. Let's do a cd on the directory. ls shows nothing. So let's go back to home directory and ignore the MapReduce. Now we will export the input file into the cluster. We open FileZilla. Before entering the information about the host name, let's go to FileZilla settings. On secure FTP, make sure that the key is already there. That's right there, so click OK. We enter the host name. I'm simply pasting the SSH string and then removing anything that is before EC2. The username is Hadoop, password empty, connection port 22, click Quick Connect, click OK to trust the host, and the connection is established. Now we drag the input file nysc_data.txt to the Hadoop directory. You can see that the file has moved. Let's do an ls here to confirm. Let's also double check the content of this file. Let's do a nano nysc_data.txt. Nano nysc_. We'll scroll down the records, the stock, the date, the price. If you go all the way down, we see some empty lines. Let's backspace and remove these lines to make sure the file is correct. We can exit and save the changes. Now let's move this file to the cluster. Let's do an Hadoop fs -ls. You'll see that an MR for MapReduce directory is created. Inside the directory, there is nothing now. So let's move our input file there. Let's do Hadoop fs -copy from local. The name of the input file, nysc_data.txt, space mr. Enter. Just to make sure, let's do an ls on the mr, and then the input file is there. Now let's create a Python file for the mapper. Let's type nano.mapper.py. Now it's a blank file. Let's copy and paste the mapper text file into this file. So let's find nysc underscore mapper text. Double click to open that. Control A, right click, copy, and paste into the terminal. This is the Python file. The mapper is a straightforward process. You may want to pause the video and read the comments that I have provided so you have a better understanding of the actual process of the input lines that are coming from the input file. Then we save this file. Now let's create the reducer. The same way, we are going to copy the reducer text file. So let's search for the reducer, double click, Control A to select all, or simply drag and select all, right click to copy, and then paste into the terminal. The same way, you may want to pause the video and read the comments that I have placed to better understand the functions of each line in this Python code. But basically, we take the key value from the mapper, and for each key, we calculate the maximum price and emit the maximum price. Save the reducer, and before we run the MapReduce job, we need to make both the mapper and the reducer Python files as executable files. So do a change mod chmod +x mapper.py, and also do the same thing for the reducer. If you do an ls, you'll notice the change in color for mapper and reducer, indicating that these files can be executed. We need to find a streaming jar. So let's type the command find userlib -name * hadoop * streaming * .jar. Hit enter, and we are looking for this specific file called hadoop-streaming jar, which is in the indicated path here, user/lib/hadoop. Finally, let's run the Hadoop jar. Hadoop space jar user/lib/hadoop/hadoop.streaming.jar as indicated earlier. Minus files are mapper.py, reducer.py. The mapper is mapper.py. The reducer is reducer.py. And then the input file and the output directory, which, as always, should be a new directory that does not exist earlier. Hit enter, and you will see the MapReduce job being executed. You'll see the counter for the mapper. As the mapper processes the data, the report will show the progress. And then once the mapper is completed, you'll see the counter for the reducer. So as the mapper is completed, then the reducer is also completed after the mapper. Let's check the output directory. So let's do a hadoop fs -lsmr. It is there. Let's see inside the output subdirectory. You have a success log file and then the part files which have the output. Let's do a cat on these files and you'll see the final results. And that's how you run a MapReduce with Python. Go ahead and try it and let me know if you have any questions. If you want to learn more about big data analytics, subscribe to this channel. Also, follow me on Twitter at Professor Benny or join my LinkedIn network. You can always email me with any questions.